Alright, so now I'm on Driftwood Beach. There are three primary ways to solve systems of equation. I've talked about graphing, Mr. Thomas Wick talked about elimination, and now we're going to talk about my personal favorite, which is substitution. So let's get straight to it. Don't be jealous of my pretty driftwood.
Welcome to Unit 2B, Lesson 3. We're going to be solving systems by substitution. This is my personal favorite method, so I'm very excited to be the one to get to explain it to you. So our learning target is that we're going to solve systems using the substitution method. The thing is, graphing, though it's easy because we're good at graphing equations, it's not always practical because sometimes systems might not have perfect little answers. They might have a solution that's a decimal, or it might be values that are really, really huge and it's just not going to be practical to graph them on the coordinate plane. Luckily, we have algebraic methods, a couple of them actually, to help solve this problem. So the first thing to remember is the substitution property of equality, which, remember, the substitution property of equality says that if we know two values are equal, we can replace them with each other in any equation or expression. This is going to be the main thing we need to use here, and we're already used to using it. We used it all the time back when we were evaluating expressions before we started solving equations. So let's see how this is going to be used with solving a system. So when I see something like this, basically I know that y is equal to negative x plus 3 in this equation. And the second equation, I know that y is equal to x plus 5. The thing about it is, if y is equal to this, then I can replace y with negative x plus 3 anywhere I want. So what I'm going to do is I'm going to take this negative x plus 3 and I'm going to plug it in place of y. So when I rewrite that, instead of writing y here, I'm going to write negative x plus 3. It's still going to be equal to that x plus 5. And now I have an equation that you already know how to solve. I don't have any distribution or anything. I'm going to start moving all my variables to the same side. I see this negative x, so I'm going to add x to both sides. That leaves me with just 3 here. Over here, x, remember there's a 1 here. So 1 plus 1 is 2x plus 5. And now I can finish solving by saying minus 5, minus 5. 3 minus 5 is negative 2. Over here, I have 2x, and 5 minus 5 goes to 0. When I divide by 2, I get x equals negative 1. All right, if this were back in the last unit, we would be finished with this problem because we have a nice pretty x equals, but I have to keep going because I also need to know what y equals. So what I'm going to do now is I'm going to go back up into one of my equations. Absolutely does not matter which one, and I'm going to replace x with negative 1 because I now know that the x coordinate of this solution is going to be negative 1. But as we learned when we were graphing, we need an ordered pair. I need both my x and my y value. So I'm just going to go into this first equation, and this is negative x, but in place of x, I'm putting negative 1 plus 3. Negative and a negative make positive, so this is just positive 1 plus 3, and 1 plus 3 equals 4. You could also plug this in here just to make sure. Negative 1 plus 5 would also equal 4. So regardless of where you put it, my solution is negative 1, 4. Make sure you rewrite it as an ordered pair so that you can make sure that you've given me both an x value and a y value. All right, let's go look at another example that might not be quite so simple. So this time, again, I have a y that's already isolated. I know that y equals negative 2x minus 1. This time it's not quite as simple as just plugging it straight in, but I can still substitute in place of this y right here. So what I'm going to do is I'm going to rewrite, I don't know why it won't stay skinny. All right, I'm going to rewrite this equation, but instead of putting y, I'm going to put negative 2x minus 1 because I know that y is equal to negative 2x minus 1. And the substitution property of equality says that if I know what something equals, I can substitute it anywhere I want. So now I'm going to solve this equation. I'm going to start by distributing, because if I have any kind of distribution, I do that first. So this is a positive 2, and I'm saying 2 times negative 2 is negative 4x. 2 times negative 1 is negative 2, and that equals 12. Now, 4x minus 4x is 0. So I have 0 minus 2 equals 12. Well, 0 minus 2 does not equal 12. It equals negative 2. Because that is not true, that means the solution here is there is not one. There is no solution. This is a situation where if I tried to graph this, it wouldn't have worked out. I wouldn't have been able to find anything. So those would have been parallel lines that never ever touched. So there's no solution, and I get to move on. Right, example 3. This time I have my x isolated instead of my y, so I am going to still substitute. I know that x is equal to negative 2y plus 5, so I'm going to substitute that in place of this x. Try to use parentheses there because it helps remind you that you're going to have to distribute this 2 to all these different terms that are equal to the x. So what I'm going to do is I'm going to have 2, and then in place of x I'm putting negative 2y plus 5, because that's what x is equal to. And then I put the rest of my equation down exactly as it was, and now I'm going to use my solving methods. I've got to first distribute. So 2 times negative 2 is negative 4y, 2 times 5 is positive 10, and I have 4y equals 10. All right, when I start combining my like terms, I have negative 4y plus 4y. That again goes to 0, except this time what's left behind is 10, and 10 does equal 10, which means this is going to be infinitely many solutions. So again, I don't have to continue on. I don't have to try and figure out what y equals, because basically no matter what I plug in for x and y, it's going to come out to be equal. So infinitely many solutions. If I had graphed this, I would have ended up with 2 lines that were right on top of each other. All right, one more example. In this case, neither one of the variables are isolated. I don't know exactly what x equals or exactly what y equals right now. So what I'm going to do is I'm going to pick one of the equations and solve it for one of the variables. It doesn't matter which equation I pick. It doesn't matter which variable I pick. I'm just going to inspect these to try and figure out which one's going to be easiest. In this case, the easiest one to isolate is going to be this x because it doesn't have a coefficient. So I'm going to come over here and say 4y plus x equals negative 4, and I'm just going to solve for that x, which means I need to subtract 4y from both sides. That leaves me with x equals negative 4y minus 4, and now I'm ready to substitute. So now I'm going to take this negative 4y. I know that it is equal to x, so I'm going to substitute it into my second equation in place of that x. So I'm going to say 3 times negative 4y minus 4, because that equals x, plus 5y equals 2. So everything other than that x is going to stay exactly the same. And now when I solve it, I'm going to distribute. 3 times negative 4 is negative 12y. 3 times negative 4 is negative 12, plus 5y equals 2. I'm not distributing to this term because it's not inside of those parentheses. So now I'm going to combine my like terms. Negative 12y plus 5y is negative 7y minus 12 equals 2. I'm going to add 12 to both sides of my equation, which leaves me with negative 7y equals, that goes to 0, 2 plus 12 is equal to 14. And when I divide by negative 7, I get y is equal to negative 2. All right, now, I now know one of the coordinates of my ordered pair. I've got to figure out what x is, though. So I'm going to go back into my equations, pick one of them. It absolutely does not matter which one. I'm going to go with this first one again, just because I think it's going to be easier to work with because it's got fewer coefficients. So I'm going to say 4, and instead of y, I'm using that substitution property again and putting negative 2 in place of y, because I now know that y is going to equal negative 2 in my solution. So I'm going to say 4 times negative 2 plus x equals negative 4. And I'm going to solve. 4 times negative 2 is negative 8. And this is a negative 8, so I'm going to add 8 to both sides of my equation, which leaves me with just x. And negative 4 plus 8 is positive 4. So the last step is going to be to write out my solution. So my x coordinate is 4, my y coordinate is negative 2, so my solution is the ordered pair 4, negative 2. Please make sure that you put your x value first, your y value second, because that's how we organize all ordered pairs. Let us know if you have any questions.